Hi, pre-calc students. This is Hyperbolas Day 2. So we're going to be taking a look here today at some more sketching of hyperbolas, identifying all the key critical info. And then we'll also see how to get a hyperbola into standard form with a little bit of completing the square, just like we've done with the other conic sections. But of course, there's maybe some slight nuances that we want to pay attention to that make it a little bit different. So the first example, this is a hyperbola already in standard form. So just a kind of a quick recap of what you saw on day 1. Let's go through a quick list of the critical information here, and then we'll make our sketch. So the center of this one's going to be at 3, -2. Just be kind of cautious with that you make sure you get the x value from the center from the x's. The value of a is 3. A is always first in these, right? Not because it's the biggest number. So we just have to make sure we keep that separate. B is going to be 4. And then the way we calculate c to get to the foci is that c squared equals a squared plus b squared. So that's going to be, in this case, 9 plus 16, which is 25. So if c squared equals 25, that gives us the value of c equal to 5. So we've got the values of a, b, and c. We know the center. And I guess really the last main critical piece of info that we'd want to be pretty confident with is that this is a hyperbola that opens up and down because the y's come first. I might have used the phrase like y goes to the sky. So if y squared is the positive quantity, which I always list the positive quantity first, it's going to open up and down. So let's go ahead and plot the center at 3, -2. From there, I'm going to use the value of a to go up and down to get to the vertices. So that was a distance of 3. So go up 3 and then down 3 to get to the vertices. Can label them as v and v prime. If we go left 4 and then right 4, it's going to get you to the ends of what are called the conjugate axis. Okay, it's not the minor axis anymore, especially in this case, because it's not the smaller of the two axes. All right, go ahead and draw a box or a rectangle that connects through those 4 points. And then the diagonals of that rectangle are pretty critical because those are what give us the shape of the hyperbola. Okay, so extend them out to the ends of the graph there. While I'm at it, I probably should include the foci, which were going to be up 5 and down 5 from the center. And the hyperbola branches are going to open up and eat the foci here. So you're going to get a graph that looks something like this. Okay, hopefully that all kind of makes sense with what we saw in the lesson the other day. So then from there, the only other thing that we have to do is list some of the important coordinates. So based on the fact that everything's centralized at 3, -2, we went up and down 3 to get to the vertices. So that's going to be 3, -2 plus or minus 3. To get to the ends of the conjugate axis, we went left and right 4. So to 3, we're going to add and subtract 4, keep the y value -2. F and f prime went up and down 5. So that's going to be 3, -2 plus or minus 5. The LR has a length of 2b squared over a. So b squared in this example is 16 and a is 3. So that's 32/3. So then to get to the ends of the LR, so remember, here's my LR segment right there. And then here's another one down here. Okay. So we know that the ends of the LR have the same horizontal y value as these y values, -2 plus or minus 5. But from the x value of 3, we have to add and subtract half the length of the LR. So if this is 32/3, cut that in half to get 16/3. And then the y value are the same as the foci, -2 plus or minus 5. Last thing, don't forget about them. We got some asymptotes. Okay, the asymptotes contain the center of the hyperbola, which is the point 3, -2. So the lines that represent the asymptotes are y plus 2 equals some slope times x minus 3. You can kind of just steal those right from up here. Just don't square them because we're talking about the equation of lines. So remember that the way we get that ratio is from the center. What did I do? I went up and over, rise over run. I went up a and I went to the right b. Okay, so the ratio of a over b is 3/4 in this one. Just throw a plus or minus in front of it because we have the positive slope and that negative slope line. So the asymptote equations are y plus 2 equals that plus or minus 3/4 times x minus 3. Okay, so that's kind of a quick one to get us started here. Hopefully that wasn't so bad. And the only new thing today, like I was mentioning, is now we're going to have to talk about how do we complete the square to get this into standard form such that we can sketch the hyperbola pretty easily. All right, so in order to accomplish this, what we're going to start by looking at is we want to group the x's, group the y's, and then anything without x or y will move to the other side. Okay, I'm going to do 25x squared plus 50x minus 36y squared minus the 144y. Okay, we're going to add the 1019 to the other side. Okay, so now we're kind of setting the stage to complete the square. So we know that in order to do that, we've seen this with ellipses. You're going to have to take out the GCF of that coefficient that's in front of x squared in this case. So that's going to leave me with x squared plus 2x plus blank. I'm also going to have to take out the negative 36. And here's where students tend to make some mistakes. When you factor out a negative 36, keep in mind you're taking a negative 36. You're dividing this by negative 36 as well. So it's going to be y squared. A negative divided into a negative would be now a plus, and that's going to be 4y plus blank equals 1019. And of course, we need some blanks on the other side to kind of keep this balanced. Okay. So I think it will be pretty easier for us to say, all right, if I look at the first blank, 2 divided by 2 is 1, squared is 1. So that's what completes the square. But of course, we didn't really just add 1 to that side. We added 1 times 25. So to keep this balanced, you have to add 25 to the other side. Okay, same thing with the y's. To complete the square here, 4 divided by 2 is 2, squared is back to 4. But I didn't really add 4 to the side. I added 4 times negative 36. So 4 times negative 36 is minus, we added a negative amount, right? Minus 144. So that's a huge difference with what we saw with ellipses. There's always plus plus for ellipses. Now you'll see for hyperbolas, it's just plus minus. Be really careful. I know it's so easy to lose track of what's happening when you take out a negative there, okay? So from there, you're gonna get 25 times x plus 1 squared minus 36 times y plus 2 squared equals, I have a feeling that whatever that number is on the other side, it's what 36 times 25 is. We'll check it out in a second. So this is 900. And yeah, 36 times 25 is 900. Okay, so we see that happen a lot, right? The product of these numbers is this. It doesn't have to be, okay, we've talked about that before. But if you divide both sides by 900, the final answer would be x plus 1 squared over 36 minus y plus 2 squared over 25 is equal to 1. So now this looks sort of just like the first example. We can hopefully pretty easily make a sketch of it, find a, b, and c. So we'll do that now. And then once we're done with that, we just have a few more for practice here. So the center of this hyperbola is at -1, -2. The value of a would be 6, not because it's largest, but just because it's first. B is 5. C squared in this one's going to equal a squared plus b squared, so 36 plus 25 for a total of 61. So C is going to be the square root of 61, which is approximately, well, it's somewhere between 7 and 8, right? Square root of 61 is about 7.8, so I'll use that value when I go to start plotting here in a moment. Oh, and since x squared is the positive one, x comes first. This hyperbola is going to open up left and right. Okay, let's get right to the plotting then. We've got -1, -2 as the center. Since the value of a is 6, that's going to get me to the left and right points of the vertices. The one, let's see, that's 6 to the right. 1, 2, 3, 4, 5, 6 to the left. Here's v and v prime. If you go up 5 and then down 5, going to get you to the ends of the conjugate axis. By the way, the connection from v to v prime while I'm doing this here is called the transverse axis, in case that term comes up again sometime soon, which it should, I think, tomorrow. All right. So we draw the box through those 4 points, draw in the diagonals for the asymptotes, and then from there, we know the hyperbola is going to branch out through and connect to the vertices. Don't forget to include where those foci are though. So if you go 7.8, so just about 8 to the left and to the right of the center, we've got those foci in there too. Okay, now that we have all that, I haven't left myself a ton of space, but I think I can fit it. Let's squeeze in what are all the important coordinates here. So the vertices v and v prime went left and right, so it's -1 plus or minus 6, comma, -2. B and B prime went up and down, -1, comma, -2 plus or minus 5. Foci went left and right. Keep it as radical 61, right? Don't use the decimal approximation. So -1 plus or minus the square root of 61, comma, -2. Okay. LR is 2b squared over a. B squared in this one is 25. And that's going to be over a, which is 6. So that's 50 over 6. I realize that reduces, but you don't even have to, right? That would be like 25/3 in this case. All right, the ends of the LR, E and E prime, that's the ends of these vertical segments here. So those are going to be in line vertically with the foci, so -1 plus or minus radical 61. From the -2, we have to add and subtract half of that, which would be 25 over 6. Sorry, I have to kind of squeeze that in there. Hopefully you can read that. -2 plus or minus 25 over 6, but of course we're not done. We need the asymptotes, which contain the center. So we've got y plus 2 equals something, some slope times x plus 1. When it's horizontal, you're rising b and running a. So it's plus or minus the ratio of b over a, which is 5 over 6. Okay, so just about barely fit that in there. If that was at all too fast, hopefully you guys can hit pause, get caught up. But I'm going to jump right into the example number 3 on the back. I'll do this one with you, and then I'll encourage you to try the last one on your own, but this is the last one that we'll kind of do together. When you go to complete the square for this one, I'm going to encourage you to, in this case, whichever squared term is positive, leave it first. Because when we have hyperbolas in standard form, we typically see the positive squared term first. So even though we're kind of not used to maybe listing a y squared term first, kind of leave it out there. So 12y squared plus the 72y is going to go together, minus 4x squared plus the 16x. And then I'll subtract the 44 to the other side. Okay, now we can take out the GCF here. So if I take out a 12, we get y squared plus 6y plus blank. Take out the -4, we get x squared. Just careful, when you take -4 from positive 16, now you get minus 4x plus blank. Okay, that's one of the most common things that students make mistakes with. Is it a huge deal in the end if I don't have the right sign here? Not really. If you think about it, all that really it affects is actually the coordinate of the center. Everything else should be correct. But I want you to get the center right, so try to avoid that mistake. All right, so we've got -44 on the other side. Just to set the stage, I'm going to put plus blank and then minus blank. Because we saw whatever I add in here is being multiplied by a positive, but whatever I add here, I got to multiply it by a negative. All right, so this is going to be a 9, right? And I'm really hoping, I think 9 times 12 is 108. I'll double check that in a sec. And then here it's going to be a 4 to complete the square. So I'm going to have to subtract 16 to kind of keep this balanced. This becomes 12 times y plus 3 squared minus 4 times x minus 2 squared equals, and again, I'm pretty confident 12 times 9 is 108. It is. Minus 16 minus the 44, though, is a total of 48. And we're not super surprised because 12 times 4 is 48. But if you divide by the 48, you would get y plus 3 squared over 4 minus x minus 2 squared over 12 equals 1. Okay, so we're now ready to sketch. Here's what I would actually recommend doing. I would hit pause and I would try the rest of this these set of notes. So I would go through, graph this, identify all the key info, go ahead and go down to number 4, try that one as well. That's the first one that you're going to try and complete the square on your own. And then from there, if you feel like you've done it correctly, graph it, find the coordinates, and then hit play and kind of go back and check in here. I think that's the best case scenario, okay? But I'm going to run through my thought process. So if you do get stuck, certainly hit play and kind of join back in here. The center of this one's going to be at 2, -3, right? X value from the x's. Value of A is 2, and B is the square root of 12, which is about 3.5 for graphing purposes. C squared is going to equal 4 plus 12, which is 16. So C is therefore 4. The y's are first, so it's going to open vertically up and down. That's all I need to make my sketch. So let's go ahead and start sketching here. We've got 2, -3 as the center. The vertices go up 2 and down 2. Here they are. We've got left 3.5 and then right 3.5 for B and B prime. Okay, go ahead and connect those. Draw on the asymptotes. You can actually at this point now draw the hyperbola in. Okay, the foci are actually 4 away, right? Okay, so there's my complete picture. From there, I can go ahead and start listing some coordinates. So we've got the vertices V and B prime, those went up and down. So it's 2, -3 plus or minus 2. For the ends of the conjugate axis, they went left and right, radical 12. 2 plus or minus radical 12, -3. For any of you asking or thinking about, do you have to simplify the radical? The answer, in my opinion, is no. All right, F and F prime went up and down 4. So 2, -3 plus or minus 4. The LR is 2b squared over a, so b squared in this case. Okay, if b is radical 12, it's actually 12 over a, which is 2. So the 2's would actually cancel out there. The LR is a nice length of 12. So to get to the ends of the LR, we're going to, from an x value of 2, add and subtract 6, half the LR, and it's going to be in line horizontally with the foci. And the last step here is to write the equations of the asymptotes. So for the asymptotes, it's going to be y plus 3 equals, what's the slope here? We rise a and run b, so it's plus or minus 2 over the square root of 12. Not the nicest looking slope, but who cares? And then we get times x minus 2. So for that last part, don't worry about rationalizing this. I mean, it actually does simplify kind of nicely, but I'm not testing you right now on your ability to simplify and rationalize denominators, okay? I'm really testing you on, can you write the equation correctly of asymptotes? If you did happen to simplify, great. You'll still get full credit, of course, as long as you do it correctly. Okay, so that's the rest of number 3.